Today, we're going to pull back the curtain on the architects of our automated future, the robotics engineer. We're diving deep into who they are, what they do, and how they are quite literally building the world of tomorrow, one smart machine at a time. You know, it all really boils down to one huge, almost science fiction question. How in the world do you build a machine that can actually think, sense its surroundings, and act on its own? This is the core challenge that robotics engineers get up and solve every single day. And let me tell you, this isn't some far off in the future problem. It's a challenge that's more urgent than ever, and it's being driven by a massive demand from modern industry. Let's take a look at why. Think about it. From manufacturing and logistics to life-saving medicine, the demand is just exploding for machines that do way more than simple, repetitive tasks. What we need now are systems that are intelligent, incredibly fast, and maybe, most important of all, completely and totally safe. So who answers this call? Who steps up to build these smarter, safer machines? Well, it's time to meet the hero of this story. I love this quote from Hussein Lazayek because it just perfectly captures what this role is all about. A robotics engineer isn't just one thing. They're this powerful mix of a software engineer, a robotics expert, and an applied scientist all rolled into one. In short, a robotics engineer is the ultimate integrator. They're the ones who pull together all these different fields, mechatronics, which is that cool blend of mechanics and electronics, plus computer science, plus electrical engineering, to create these complex systems that can actually see, feel, and interact with the physical world. Okay, so this is a big one. People mix up robotics engineers and automation engineers all the time, but here's the key difference. A robotics engineer is focused on creating the physical robot itself. The automation engineer, they're focused on automating an entire process or system, which, might involve a robot, but it might not. So what does it actually take to become one? Come on, let's open up the engineer's toolkit and see what skills you need to have. First and foremost, you gotta know software. You could almost say that at their heart, robotics engineers are software engineers. Python is absolutely key for getting ideas up and running quickly, but when you need that lightning-fast, real-time performance on the actual robot, what we call on the edge, C++ is your best friend for pure speed. But hey, it's not all just ones and zeros. They have to be masters of the physical world too. That means using computer-aided design, or CAD, to actually design the robot's body. It also means having a deep, deep understanding of the sensors that let it see, the actuators that let it move, and the microcontrollers that act as its tiny little brain. And listen, the toolkit isn't complete without these core human skills. Technical know-how gets you in the door, sure, but to really succeed, you have to be an innovative thinker, a super logical problem solver, and have almost obsessive attention to detail. And since robots are always built by teams, being a great collaborator is non-negotiable. All right, so we've got the skills. Now let's see how it all comes together to solve a really, really tough, high-stakes problem. Okay, picture this. You've just built this amazing, powerful industrial robot. But how do you prove it's safe? You can't just, crash it a million times to find that one super rare edge case bug that could be catastrophic. It's just too dangerous, way too expensive, and it would take forever. The answer is brilliant: real-time simulation. So first, you model those weird, rare edge cases in a virtual world, things like a sensor flickering for a millisecond. Second, you run thousands of tests in what's called software in the loop, or SIL, to hunt down any logic errors. And finally, you connect the robot's actual physical controller to the simulation in what's called hardware in the loop, or HIL, to confirm it behaves perfectly. And what's the result of all that? It's one word: confidence. You get speed, you get perfect repeatability in your tests, and you guarantee safety. You prove the robot's logic is absolutely solid before a single piece of real metal ever has to move. It is a total game changer. So, feeling inspired yet? If this sounds like your kind of thing, let's talk about how you could actually build a career in this incredible field. Here's the roadmap. It all starts with a bachelor's degree in a related engineering field. Next, you've got to get your hands dirty with internships. Then, and this is super important, build a portfolio of your own projects to show people what you can do. And finally, get out there and connect with people in the industry. So what's the reward for all that hard work? Well, in the US, this is a pretty typical starting salary for an entry-level robotics engineer. Right out of college, ready to put all that knowledge to work. Now, get a few years of experience, build up some specialized skills, and that median salary jumps up significantly. This really shows you how high the demand is for engineers who can deliver real proven results.
And for the true experts, the folks with deep knowledge in hot areas like AI, machine vision, or autonomous navigation, salaries can easily climb to $145,000 and even higher. It just shows the incredible potential for growth here.
But look, this isn't just a job with a great paycheck. This is about being on the front lines, actually building the future. Let's look at the kind of impact we're talking about. The real-world stakes here are just incredibly high. We're not just talking about making widgets faster. I mean, at a company called Multiply Labs, engineers are using robotics to automate the creation of cell therapies. We're talking about treatments that can literally save lives. This is technology with a profound, undeniable human impact. Make no mistake, our world is being completely rebuilt from the ground up with code and with robotics. It's happening right now in medicine, in manufacturing, everywhere. The only real question left is, who's going to be its architects?